Hello again, everybody. We're in section 4.2 still. We're working on applying congruence and triangles. And in this section, we got our second goal. We're going to learn, or in this video, we're going to learn to solve problems involving corresponding parts of figures. Alright, now in the last video for this section, we learned how to determine if two figures are congruent by using their corresponding parts. So you already know what corresponding parts are. Now again, we're going to solve problems that involve corresponding parts of figures, both congruent ones and non-congruent ones, where applicable. Alright, so let's take a look at some figures that are congruent to one another and see how we can use their corresponding parts in order to answer some questions. Alright, in this picture, you can see that we've got two triangles that are congruent to one another. And I want you to pay attention to the congruent statement here because this is super important. We could actually answer every one of these questions without looking at the figures over here if we're given this congruent statement. But anyway, it says triangle ABC is congruent to triangle XYZ. And we want to copy and complete the following statements that say, well, some various things that you see right there. Go ahead and take the moment to copy these down. And then let's figure out what's congruent to segment AB, what's equal, or what's congruent to triangle YZX, and so forth. Alright, now the reason I say that the congruent statement is so key is because remember when you write a congruent statement for two figures, it puts the corresponding parts of those figures in a corresponding order, so to speak. So when you see, for instance, that A is listed first here and X is listed first there, that means that angle A from this triangle will correspond with angle X from that triangle. And you can kind of envision that in the figure. Doesn't angle A correspond with angle X? Now, let me talk about another little aspect of congruent figures that I want to remind you of very frequently right now that will back up that statement. Every time you have congruent figures, there's some kind of transformation that you can do to one of them to make the other one, meaning a rotation, a reflection, or just simply a shift. And I hope you can tell how in order to get the second triangle from the first triangle, we could just make use of a rotation, right? If you rotate this triangle, it looks like something like 90 degrees, you would end up with this triangle right there. And so thinking of it that way, it makes sense that segment AB and segment XY correspond with one another. So that's our answer for part A. And finishing my thoughts on the congruent statement that's there, you can kind of see how AB comes first and then XY comes first on the other one. So that's another way of telling that segment XY is the one that corresponds to segment AB. Make some sense? Alright, you should fill out the rest of these on your own. Check your answers here in just a moment. Alright, so you figured out now that angle C is congruent to angle Z by either noticing that they were both in the same spot in their congruent statements, or that if you rotate angle C over to this triangle, that it corresponds with angle Z. Alright, and now just notice the difference in notation from part A to part C. I don't have the segment symbol. Here I'm saying the distance from C to A equals, rather than saying segment CA is congruent to something. Well, the distance from C to A is going to equal the distance from Z to X. And now you might think, haven't we already stated that these two triangles here are congruent to one another? So why would we make another congruent statement out of triangles? Well, it's just to see if you know how to get the corresponding parts in order, really. Triangle YZX is congruent to. Now, you can name a triangle use in whatever order you want to in regards to its vertices. I could call this triangle XYZ like I did in this first congruent statement. I could call it triangle YZX like I am in this congruent statement. I could call it triangle ZXY. There's several possibilities, right? But depending on the name that you choose for the first triangle to congruent statement, that will determine what you call the second one. So we want to make sure we get the corresponding parts from this triangle in the same order as YZX. And so that'll look like this. Since angle Y corresponds with angle B, we would put that first. Since angle Z corresponds with angle C, we would put that second. And then angle X corresponds with angle Y, so we would put that third. Make sense so far? Good. Alright, got a couple more congruent figures for you. Now notice I didn't use any symbol for these figures right here like I used for a triangle or a segment or anything. I'm just saying that PQRS is congruent to EFGH. Once we get past triangles, you don't have to use symbols to indicate how many sides a figure would have. If you just have 4 vertices, that means it's a quadrilateral. If I had 5 of them, it would mean a pentagon and so forth. Okay, but at any rate, since these figures are congruent, we're going to be able to find the values of the variables that you see in the pictures. Alright, now again, let's think about this congruence and how you would take this figure in order to make this figure. And I hope you see that you would reflect in a horizontal line. These are kind of mirror images of one another, right? If you were to flip over this line right there, it would basically give you this figure right here. There was a little shift involved as well. Alright, well, the corresponding parts of congruent figures have to be congruent to one another. And so what we want to do, say if we were going to find 4x minus 6, well, that's the measure of angle E. We'd want to see what angle from the other figure does angle E correspond with. That, of course, would be angle P, right? You can tell it here as well as down with the figures. Since those are congruent figures and those corresponding parts then are going to have to be equal to one another, we can make an equation out of the 74 and the 4x minus 6, looking like this. And then once you do that, let's just go ahead and solve. If we add 6 to both sides, we would get 4x equals 80, and then you divide by 4, you're going to get x is equal to 20. Alright, see if you can solve the other missing variables. Alright, so you should have made the equation 3y equals 21, because doesn't segment GH correspond to segment RS, and since the figures are congruent, that makes those segments congruent to one another. So this distance equals that one. So you simply got y equals 7. And then you made this equation in order to find the value of z, because angle R corresponded with angle G, which was 90 degrees, so set those angle measures equal to one another. Then if you subtract 8, you get 8x equals 82, and 82 divided by 8 ends up being 8.25, or 8 1/4, or 33/4, however you want to write that. Alright, good. So that's using congruent figures in order to find measures of corresponding parts. Now we're going to look at a theorem that involves a way you can find measures of corresponding parts when you have two figures that are not necessarily congruent to one another. And it's something called the third angles theorem. And the third angles theorem applies to triangles that have two pairs of angles that are congruent. Now you can see hopefully pretty clearly, I know you don't always trust the diagrams, but let's assume you can here. You can see pretty clearly that this triangle ABC is not congruent to triangle DEF. They're nowhere near the same size, and you have to be the same size and shape for two figures to be congruent. However, it does have two angles that are congruent to one another. Angle A is congruent to angle D, and angle B is congruent to angle E. So let me write that real quick. And I'm going to write this in if-then form so I can finish the theorem that we're trying to learn. You see that angle A is congruent to angle D, and you see that angle B is congruent to angle E. Now what conclusion can we make about anything in these triangles knowing that they have two pairs of angles that are congruent to one another? We'll think this through. Don't the three angles of this triangle have to add up to 180 degrees, and the three angles of this triangle have to add up to 180 degrees? Now, if whatever this pair of angle measures adds up to, this pair of angle measures has to add up to the same thing, right? Because both pairs of angles are congruent. So what that's going to allow us to conclude then is that the third angles in the two triangles, C and F, have to be congruent to one another as well. Alright, angle C has got to be congruent to angle F. Alright, so the third angles theorem would say that if two angles from one triangle are congruent to two angles from another triangle, then the third angles of those triangles must be congruent to one another. Let's see how we can apply that. We're going to use this picture here, where you have two triangles that are not necessarily congruent to one another. They don't look like they are anyway. And we're going to use this picture to find the values of x and y. Now, looking at the diagram, you can tell that we have two pairs of angles that are congruent. These angles are congruent to one another, and this angle are congruent to one another as well. Alright, now the first thing I want to do is apply the third angles theorem. If we know that two pairs of angles are congruent between the triangles, then the third pair of angles has to be congruent as well. And I'm going to mark that down here on the diagram. There you go, so you see that these pairs of angles are congruent. Let's see how that helps us. We want to set corresponding angle measures equal with one another. Alright, so for instance, we know that this is 4x plus y and that angle measure is congruent with this one, so we can make an equation 4x plus y equals 31. That equation will be helpful to us, but the problem with it is that it's one equation that happens to have two different variables in it. And so as you may recall from algebra, if you have two different variables that you got to find, you need two equations to solve for them. So we're going to need one more equation equating congruent angle measures between these two triangles. So I got to figure out how to relate either this pair of angles or this pair of angles. One of those things will get us somewhere, the other one won't necessarily get us anywhere. Here's the one that won't really get us anywhere. I know that this angle is 85 degrees, so that means that this angle over here is also going to be 85 degrees. But the best I can do with that is say 85 equals 85. Neither of those angles involves x or y. So we need to go to the other pairs of angles right here and right there, and we need to be able to set them equal to one another. The problem is that even though we know this one's 10x minus 2y degrees, we don't know what this angle measure is. Easy enough to find though, isn't it? Because can't you just add up the 85 and the 31 and subtract from 180 to figure out what this angle measure is? Alright, well, let's do that then. 85 plus 31 is 116. If you subtract 116 from 180, you're going to get 64 degrees. And so we're able to conclude that this 10x minus 2y is equal to 64. Now, embedded within this geometry problem, I'm trying to remind you of an algebra skill that you need to have, and that's how you solve a system of equations. We have these two equations with two variables in them now. We've got to be able to figure out what method we might use in order to solve for x or y. And the method I'm going to choose to use is the elimination method, which hopefully you remember is when you add the two equations together in the hopes of either canceling the x's or the y's so that you can solve for the remaining variable. Now, in order for that to happen, you need either the x's to be opposites of one another or you need the y's to be opposites of one another. I hope that you will also recall that you can multiply both sides of, both sides, but you can multiply an entire equation by whatever constant value you want to. And so what I'm going to do is I'm going to multiply this top equation by 2 so that this will become a 2y, because 2y will cancel with negative 2y when I add the equations together. And that's going to make this system of equations look like this. Alright, notice I doubled everything to get this equation right there from the first equation. Now what I'm going to do is I'm going to add those two equations together. Then I'll bring down the equal sign. And I'll add the constant 62 plus 64, which is going to give me 126. Then it's just a matter of how many times does 18 go into 126. Happens to be 7 times, so x is equal to 7. And then once I find the value of x, how do I find the value of y? Well, I'm going to use substitution. I could take either of these equations or either of these equations and replace x with 7 in order to figure out what y is. Let's just say I take the very first equation and make that happen. You can see how I substituted 7 in place of x in that first equation. Alright, and then 4 times 7 is 28. I'm going to have to subtract that from both sides of the equation. 31 minus 28 is 3. So we just figured out that y is equal to 3. And so in this case, since my answers are kind of scattered around, it makes sense to highlight them to make sure we know which ones are the answers. X equals 7, y equals 3. Alright, that's how you use corresponding parts of figures, both of congruent figures and of non-congruent figures. Hope this makes some sense. Good luck with your exercises on 4.2. See you in class and in the next video.